Hey, this is Mr. Ayton, and it is week 9 chemical reactions, and this week we're going to be reviewing all of our reactions from weeks 1 through 8. And I've just in random order placed all the 16 reactions from the 8 weeks, and we're going to go through them so you can quiz yourself and you can understand these even deeper. Our first reaction is solutions of potassium carbonate and zinc acetate are mixed. Since there's two solutions, I know it's a precipitation reaction. So I got to figure out who my spectator's ions are. Potassium's a spectator ion because it's an alkali metal, which means acetate's a spectator ion. I'm going to put the zinc first, and since it's a solution, I need zinc's charge, which is +2. Carbonate's going to go next, and carbonate has a -2 charge. That's CO3 -2. And when zinc +2 and carbonate -2 comes together, it's going to make zinc carbonate, which is a solid precipitate. It's already balanced, so we're good to go with that reaction. Our second reaction is solutions of carbonic acid and ammonia are mixed. This is an acid-base reaction. Carbonic acid, I got to figure out, is it a weak or strong acid? Carbonic acid is weak, so I got to put H2CO3. Ammonia is a weak base, so I'm going to put its formula NH3. What do acids always do? Acids give away H+, and so what does NH3 become? Is NH4+, a conjugate acid. And what does the H2CO3 become? It becomes HCO3-, the conjugate base. This reaction's totally done balancing, so we're good to go. Our next reaction is equimolar solutions of sodium chloride and silver nitrate are mixed. We have two solutions. What kind of reaction? Precipitation reaction. Precipitation reaction, I got to figure out who my spectator ions are. Sodium, of course, is a spectator. Nitrate is as well. So I put silver first, and with its charge, since it's a solution. With chloride, with its charge, since it's a solution. And Ag+ and Cl- give me AgCl, that white solid precipitate. Our next reaction is a solution of lead nitrate is added to a solution of sodium iodide. Again, two solutions. What am I looking for? My spectator ions. Sodium's a spectator ion, which means nitrate's a spectator ion. Lead is a solution, so I got to put Pb, which is lead, plus its charge, +2. Iodine needs its charge, which is I-. When this comes together, we got to make sure we do the crisscross in order to get the right formula, and we get PbI2, which is a solid. And we know what kind of solid it is. It's that bright yellow school bus colored solid. Now, since I have two I's at the end, I need two I's at the beginning, and that balances both my atoms and my charges. Our next reaction is a solution of sodium fluoride is added to a solution of sulfuric acid. Now, right away you see two solutions, but it's not a precipitation reaction. It is an acid-base reaction, since we have sulfuric acid in there. Now, sulfuric acid is a strong acid, so I need to put H+. What's it going to go with sodium fluoride? Well, sodium will be my spectator ion, so I need to put the fluoride ion, which is F-. Acids give away H+, so we end up getting the weak acid of HF, hydrochloric acid. Our next reaction is a solution of hydrochloric acid is added to a sample of solid silver sulfide. Another acid-base reaction. Hydrochloric acid is a strong acid, so I'm going to put H+, since it dissociates completely. If you see the word solid, that means I can't split up silver sulfide. Silver sulfide will go together, which will be Ag2S from doing the crisscross there. Again, the acid gives away the H+, and we end up getting H2S. Remember that gas, that hydrogen sulfide gas that smells like rotten eggs? And what's left over is silver, but it's going to be aqueous silver, so we got to make sure we put silver's charge. We do have to balance this. Since we have two hydrogens at the end, we need two hydrogens at the beginning. Since we have two silvers at the beginning, we need two silvers at the end, and that balances both our atoms and our charges. Our next reaction is a solution of ammonium chloride is added to a solution of sodium hydroxide. You look at that sodium hydroxide and you know that it is an acid-base reaction. So we got to make sure we put our ions. Sodium will be a spectator here because hydroxide is a strong base, which means chloride will also be a spectator as well, and we're just going to put ammonium, which is NH4+. Not ammonia, but ammonium. What do acids do? They give away H+, which means what are we going to get at the end is NH3 and H2O. Water. All of our atoms and our charges are balanced out, so we're done that reaction. Our next reaction is solutions of ammonia and nitric acid are mixed. Another acid-base reaction. We see nitric acid, and we know nitric acid is a strong acid, H+. We know ammonia is just NH3. And what do acids do? They give away H+, so what are we going to end up getting is NH4+ at the end. All of our atoms are balanced, all of our charges are balanced as well. Our next reaction is a solution of sodium hydroxide is added to a solution of acetic acid. Again, another acid-base reaction. We see sodium hydroxide and we say we have a strong base, OH-. What do we know about acetic acid? Is it strong or is it weak? It is a weak acid. So we got to make sure we know acetic acid or vinegar's formula, HC2H3O2. What do all acids do? All acids give away H+. What do we end up getting is water, H2O, or HOH. And what's left over is the acetate ion, which is C2H3O2 with a minus charge. All of our atoms, all of our charges are balanced out in this one, so we're good to go. Our next reaction is a solution of hydrochloric acid is added to baking soda. And baking soda, as we know, is sodium bicarbonate, or sodium hydrogen carbonate. Since hydrochloric acid is a strong acid, I'm just going to put H+. Sodium hydrogen carbonate, or baking soda, is sodium, hydrogen, and a carbonate, NaHCO3. What do acids do again? Acids give away H+, and if we give away H+, we will end up getting carbonic acid, which we know carbonic acid breaks down immediately into H2O and CO2. This is our volcano experiment where we end up getting our bubbles of carbon dioxide. There's something that's left over at the end, which is sodium, and sodium will be aqueous, so we'll make sure we put Na+. And that balances out not only our atoms, but also our charges. Our next reaction is equimolar solutions of sodium hydroxide and hydrochloric acid are mixed. Again, we have an acid-base reaction. We see hydrochloric acid. It's a strong acid, H+. We see sodium hydroxide, a strong base, OH-. Acids give away H+, and what are we going to get? Simple neutralization reaction. We get water. Our next reaction is chlorine gas is bubbled through a solution of sodium bromide. This is something different. We have chlorine gas, which is Cl2 with no charge, and it's bubbled into a solution. So this is a redox reaction. Whenever we have a solid, liquid, or gas and it's combined with a solution, we have a redox reaction. We're going to go with the bromide ion because sodium will be a spectator here. And the chlorine ends up gaining a charge, which is Cl-. And the bromine ends up becoming Br2, or liquid bromine. We do have to balance this. Since we have two bromines at the end, we need two bromines at the beginning. Since we have two chlorines at the beginning, we need two chlorines at the end. This balances out not only our atoms, but our charges as well. Our next reaction is a solution of calcium chloride is added to a solution of sodium phosphate. We don't see any acid bases here, so we know this is a precipitation reaction. We've got to figure out what our spectator ions are. Sodium's a spectator ion, which means chloride's a spectator ion. So we put calcium. Calcium's charge is +2, since it's in an alkaline earth metal. Phosphate, we got to know phosphate's formula, PO4, -3. And when we do the crisscross, we're going to end up getting a solid of Ca3, PO4, 2, which is a solid. We do have to balance this though, because you look at our charges, we got to make those into +6 and -6, which not only balance our atoms, it also balances our charges as well. Our next reaction is a bar of zinc, solid zinc, which is Zn. We don't need any charge since it's a solid. It's added to a solution of copper-2 sulfate. So this is a redox reaction. Our metal will replace the metal here. And zinc will end up getting a charge at the end, which is Zn+2. And this blue solution of copper plus 2 will end up becoming clear because of the zinc plus 2. And we're going to end up getting little pieces of copper, solid copper at the end. You can see our atoms are both balanced, our charges are both balanced as well. Our next reaction is a piece of solid zinc. Again, we just have solid zinc, no charge whatsoever, is placed in a solution of hydrochloric acid. Hydrochloric acid is a strong acid, so I put H+. Same principles as an acid-base reaction, but this is a redox reaction. Zinc ends up getting a charge, which is Zn plus 2, and hydrogen ends up becoming H2, and that's a gas. And we end up getting a pretty explosive reaction when we put a flame to this. It makes a whooping sound. And we do have to balance this, though. Take a look at our charges. We have a +1 at the beginning. We have a +2 at the end. So we need to put a 2 in order to balance both our atoms and our charges. And our last reaction, I believe, is calcium turnings. Calcium is a solid here, so we just put Ca. It's placed in a solution of iron plus 2. Now, we don't care about the sulfate because it's a spectator ion, and again, we have a redox reaction. We have a solid with a solution. The calcium ends up getting a charge. Calcium's charge is +2 since it's an alkaline earth metal, and iron ends up becoming solid. Fe, just a solid. All of our atoms and our charges are balanced out in this one, so we're done. And that is our 16 reactions from weeks 1 through 8. Good luck this week, and hope it goes well. Thanks. Bye.